you up, and we have like a screen that they see that just is like, welcome to the Meetup. And then basically I have other scenes for, this one is a full camera, and one is basically the HDMI with the camera in the lower right.
Nice.
And then,
I haven't done that.
yeah, it mostly just works.
Okay.
So that's the full camera, that's the full HDMI, which is nothing.
Mm-hmm.
Yeah, so I think we're okay right now. We can just yeah, if you do OBS on a laptop, make sure you're plugged in. Linux is like, oh, I'm going to throttle this way down. You're not plugged in.
Yeah.
So what time does the 7 o'clock meeting start?
Typically a little after 7. I don't even think Trey's here. Trey's my first speaker, although he texted me and said he's on his way. So said he'd be here at 7. And then I have my announcements all queued up, so I'll just put this over here. Oh, maybe I will try to get Trey. I'm going to send Trey something, actually.
Yeah. Let's see, somebody's at 6 hours, 59 minutes, and 30 seconds.
I'm going to send Trey something because I want him to put something on the screen for the Cloudflare sponsors so that they will refund me the money that I fronted them for the pizza. Critical.
I was wondering.
Yeah,
they've been doing it for months now? Or?
Months now. They're very slow on paying, but they do pay. Which is better than
Good.
good. Yeah.
At least it's not San Diego City.
Yeah.
Yeah, we're short $120 million, so we need to raise the taxes, and after we do that, then we can pay you.
Yeah. Let's see. I think I sent it to Jorge last time. I did. So I will just download this and send it to Trey.
So what kind of work do you do? Where if you tell me you have to shoot?
No, not quite that sensitive. I'm in the R&D department here, so mostly, traditionally we've been doing wireless R&D, so Wi-Fi for a lot of time, but now we're moving into more distributed computing, Gen AI related use cases, connection between compute and communication. Mostly, traditionally it's been more embedded work, but I've been doing more of that lately.
Okay. I think we're good. We're all set up. Go and get some water and
Round them up, move them out.
Yeah. I mean, everyone kind of knows we start like 5 minutes.
Yeah.
Yeah.
But if the first speaker isn't here, then I guess it's not quite as...
Well, I mean, there's introductions, but Trey said he'd be here. He said his ETA was 7 o'clock, so if he's not here, he's walking up.
Tony, light again.
The railings up here on the, around the edge.
Yep.
Another one here, right where I'm at now. Going first. Yeah, that'd be great. She hates that road.
She just, Red Heights, my girl. Is this good?
Yeah, you're good. I'm gonna grab another slice.
Okay.
You need anything else?
I'm good. face the other way. Okay, come here.
Right up to the road right behind you. There.
Ah,
I forget your name.
what's Juan?
Juan, that's right.
What's this?
That's just a stainless steel rail.
Is that the track?
Oh, okay.
Wall.
Got it.
Short wall. Yeah. Yeah,
You know how we do the Cloudflare slide at the beginning?
it's a sheet, right?
Sheet, yes. My name is Arrow. Bow and arrow.
I apologize to everybody that I forgot my microphone today. The room mic is fine, but the recording will be worse, and I apologize.
So far, I can hear you.
It's for the YouTube and the online people
Yeah.
so they can hear it better.
Maybe what I'll do, I'm going to move this up closer, just like this, and then maybe I can lower the volume slightly, and it will still be good. Okay. Trey said he'll be here in a couple minutes, so he is here. But he is slightly behind. And he's my first speaker, so that's okay. All right, I think we're okay. We're just going to start slightly late, and then the audio on the recording will be worse. But the room audio will be normal level.
It's too bad. I sometimes carry a mic with me in my bag. One day I didn't. I emptied it all out.
Yeah, I mean, I took my mic out today to charge it, and then charged it up, and zipped it all up in the bag, and then left the bag. Yeah, wow.
Juan and I used to work at Ira together, and he was working on a robotics project to build a guide dog, a robotics guide dog. Really? Yeah.
Gave up on that one because, yeah, back then the technology just wasn't there, and even today, that's a hard pull to get.
Exactly.
You know.
Yeah, there's a lot that you get.
A few years ago, I think,
Exactly. You just not yet. None of the models.
Not that intelligent.
Maybe in a few years, once they get the world, some of these new world models get better.
Yeah.
You know, right now, LLMs just don't understand the world.
Exactly.
Yes.
I forgot the microphone, so the audio will be worse on the live stream. I apologize. I took it out to charge today, and then
Worse on the recording too, right?
worse on the recordings. In-room audio will be normal.
I understand language.
Yep.
It's not physical physics.
There? You can sit wherever you want.
Sit, stay.
See, I'm just being simple, asking him where he wants to sit. Because it's his
So you want to do it mine, right?
Yeah, because my laptop's streaming.
Oh, right.
Yeah.
Is this USB-C also power?
I don't know. This is the dongle for that.
Oh, I see.
This is what you want. None of those are helpful. No, you want this.
But is this?
Oh, that might be power. I don't know.
It's yellow. I'm kind of guessing that means power for some reason.
It might also hook into the HDMI.
Associates yellow with power, something trained.
This is the one that I need to get the signal passed through.
Yeah, right.
But that one might be power. Let me make sure that the projector is on. That should be on.
Yeah, no, it's not plugged in yet. Just a sec. I just make sure we're off.
Is this power on? Power on. Okay, it's warm. Okay. It's showing up there.
And what? Oh, you sent me slides.
I did. But I'm hoping that this is not going through this, which I can check.
What is not?
Like, the thing that is also powering your laptop
Yep.
might also be taking HDMI, like HDMI over USB-C, or a digital video signal over USB-C.
Possible, but I doubt it, because when I plugged this in, it flickered.
Gotcha. Okay, well, we'll figure it out. I mean, I will check it in a second.
Yeah.
Well, I'm getting the same that is on there, so. Awesome.
PDF. There we go.
Good. I'm glad you were able to get them. Awesome. Perfect.
Actual full screen.
It's totally good.
It's gotta be actual full screen.
I'll let you, you can fiddle with it. I'm gonna go yell at people to
Okay,
start coming
yeah.
in. You're my first speaker, though.
Okay.
So I'm gonna do intros and then you?
Yeah, that sounds good.
Okay. And you're 25 minutes, right?
Maybe 30, but probably 25.
Okay.
It was shorter than 25 last I tried it.
Ask one more favor of you. Yep. Could I get you to take a photo of the audience and the slides?
Audience
doing
and the slides.
like
Separate.
picture? No, one picture
Good, yeah.
from the back. Just
Thanks for
Oh,
showing
I
up.
see.
get
Yes.
this and me and
For
you.
Cloudflare.
Yeah.
So it doesn't need to be a good
Our little fighter group starts to dominate this.
When are you going to do it?
I'm gonna get started like in 1 minute. Okay. Yeah. We switch us over to full camera. Nice. All right. Awesome. You're here for San Diego Python. You're in the right place. Hopefully that's what you're here for. I'm David. I'm one of the organizers, and I'm glad you're here. I want to first just go through a couple intros, and then we'll get to our first speaker. First, I want to give a big thanks to Qualcomm for having us here, and specifically to the engineering development team who kind of lines this up, and Drew and Urivan, who kind of like help with the door and make sure everything goes smoothly, Qualcomm related, and all that kind of stuff. Pizza is sponsored by Cloudflare. That's That's the pizza that we ate outside. There should be a little bit left, not too much though. I'm glad I ordered more today because there was more RSVPs, so awesome. Anyway, Cloudflare sponsors pizza. Cloudflare makes networks and websites faster and more secure. They provide awesome tools like web app firewalls and DDoS protection, R2, which is like an S3 compatible storage, and much, much more. Cloudflare network is absolutely massive, and 95% of the internet connected people are within 50 milliseconds of a Cloudflare node. And this makes your website fast and for people all over the world, which is great. And check it out. The free plan is actually really generous, and the San Diego Python website actually is on the free plan. So thanks, Cloudflare, and thanks for sponsoring. Cool. Couple other small announcements. There's a Saturday meetup. It's at 10 a.m. It's virtual. It meets on Discord. Check the meetup page. If you're on the San Diego Python website, which san diegopython.org, there's a link to the Discord. It also has when the next meetups are and that kind of stuff. The website, which is san diegopython.org, has a code of conduct. Check it out. It has a link to the YouTube channel, which this is streamed. And for the people on the stream, I'm very sorry. I forgot my mic today. And so the audio quality on the stream is going to be a little bit worse today. I took the mic out to charge it and then left it at home. Sorry. But yeah, there's a live stream. And so if you miss a meetup or something, check it out on the live stream. Or if you remember a talk and you're like, oh, I saw that 3 months ago and it was awesome, you can go back and look at it. The website links to the Discord, which is where the Saturday meetup is. There's people discussing things there. There is a jobs channel in the Discord if you're looking for work, or if your company is hiring somebody, because there's like 20, 25 people in this room right now, but if you want to get your post in front of hundreds of people who are local, you can post it there, and people check that out over time. So like you're not going to get like a flurry on one day or something, but like if you post it there over a month, a lot of people are going to see it, over 100. So that's good. There's also other channels in there for like dev, machine learning, that kind of stuff. I do want to talk about a couple upcoming conferences. PyCascades is in Vancouver, March 21st, 22nd, so it'll be before the next meetup. Check that out, that's always a good one. And then PyCon US, the big boy, that one is in Long Beach this year. And it's May 13th to 19th. The main conference is the 15th to the 17th, if you're skipping the tutorials and sprints. But, I had a note in here about how speaking at the conference, but that is totally outdated because I believe that's all done. Yeah, you're not speaking at the conference if you didn't already sign up for that. Long story short, next year, always an opportunity. But on the note of speakers, very important. The most important aspect of the San Diego Python website is the biggest button, which is the Become a Speaker, Present at the Meetup button. And that is where you sign up to give a talk at the Meetup. Very, very important. Meetup basically runs on speakers. We need like 3-4 speakers every month in order to have the content for a Meetup. And so you can sign up. Everybody who's given a talk has survived. So there's positives. And talks at all skill levels are welcome. So like if this is an intro talk, that's fine. If this is some super advanced talk or somewhere in between, that's also fine. Because the people who attend the meetup are also all skill levels. And if a talk goes over your head, well, it's only a 7-minute talk, and hopefully we get to the next one. Although today's talks are a little longer. So hopefully those don't go over your head. But anyway, sign up to become a speaker. It's great. You can do it. You don't even have to sign up for the next meetup. You can say, oh, I'm going to sign up for April or something. So sign up. Awesome. That is all my announcements. Trey Hunner is our first speaker. He's going to talk to us about variables and objects in Python. It's pointers all the way down, and this is a bit of a longer talk. And then I'll let you take it away.
Can you remove the webcam at all?
No, the webcam's here.
Oh no, I just noticed it went on the slide. Oh no, because you're going to see the slides coming from mine, right?
I'm gonna switch it over.
Yep. Forgot how that works. On the topic of speaking, you really should give a talk at this meetup. I probably gave at least a dozen talks at local meetups, most of them at the San Diego Python meetup, before I ever spoke anywhere that wasn't a meetup. And it helped me a lot in terms of just thinking of topics to give, because you don't have to speak about Python. Sorry, I gotta bring my speaker up. You can speak about anything that might be relevant to folks who show up to the meetup, like, tools that might be useful for Python folks. So if this talk title sounds familiar, some of you may have seen a version of this before. I've reshuffled it around since the last time I gave it, though. About probably half the content is new and different, so hopefully it will still be interesting. Little brief introduction about me. I help folks level up their Python skills. I do that through Python Morsels, which involves deepening your skills through hands-on Python practice. And I also do team trainings on both introductory and advanced Python topics. If you would like my help leveling up your skills or your team's Python skills, contact me. This talk is about mental models, specifically the mental models that we use when thinking about Python's variables and objects. When our mental models don't match how Python actually works, we run into gotchas. And we're going to begin with 5 gotchas. Let's say that we write a function to square all numbers in a list. If we make a list of numbers and we call this square all function with this list, it will return the squares of all the given numbers. And that's what we expect it to do. But also the original list will have been modified. It changed, which might upset callers of this function. Let's say we have a list of colors that we'd like to be keys in a dictionary. So we use the dictionary from keys class method to create a dictionary of lists. If we then add the string duck to one of these lists, every list in this dictionary will have changed. We tried to change one list, but all of them changed. So this is gotcha number 2. Let's say that we use nested self-concatenation to make a list of lists. We multiply a list with a 0 by 3 to put it in a list, and we also multiply that list by 3, and we end up with a list of 3 lists, each containing 3 zeros. So a list of zeros. If we assign the number 1 to the index 1 of the index 1, so this is index 1 of the outer list, index 1 of the middle list there, we're changing the middle element of the middle list. Sort of. We actually end up changing the middle element of every list, which is gotcha number 3. Gotcha number 4, if you think of variables as like, let's say we have a to-do list class with an initializer method that accepts an optional tasks list. Now, the given tasks list is stored as a tasks attribute on each new to-do list object. So if we create 2 new to-do list objects and we append a new task to the tasks attribute on the first object, the second object's tasks attribute will also change. If we change one of our to-do list objects, or we changed one of them, but both of them seem to change here. There are 2 distinct objects, but both of them did seem to change. Our last gotcha, if we make a first list and assign second to first, when we change first by appending to it, second also changes. But if instead we had changed first by assigning to it, second doesn't change. Changing first doesn't always change second. So, my goal in this talk is to clarify why these 5 bits of code are gotchas in Python. We'll do this by considering the mental models that we use for variables and objects. If you think of variables as like buckets that contain objects, then when we assign a variable to an empty list, that variable would contain that list. If we assigned another variable to the first one, the list would be copied into the new bucket. But if we then append 9 to our second list, that would change that list. The first list, though, shouldn't change. But in Python, as we've seen, it does change. In Python, this mental model of variables as buckets doesn't work. Variables in Python are not like buckets that contain objects. And assignment statements don't copy anything in Python. In Python, variables and objects live in 2 different places. When we assign a variable, we draw an arrow from the variable to the object. Then when we assign to another variable to the first one, we draw another variable from the second, another arrow rather, from the second variable to the exact same object as before. So when we modify our second list, the second list changes. And so does the first, because they're the same list. This is the mental model that I usually recommend for thinking about how Python's variables and objects works. And I call this the pointers mental model, because it looks like variables point to objects. But pointer is also a technical term that has a somewhat specific meaning, and Python's pointers are not like pointers in low-level languages like C and C++. At least not in the sense that they don't have dereferencing, there's no pointer arithmetic, and they're not nearly as scary or as powerful as pointers in those other languages. The Python documentation actually doesn't use the word pointer. It refers to variables as bindings, although they're also sometimes referred to as references. The reason I use the word pointer is that, to me, this word evokes something visual. It makes me think of an arrow pointing from a variable to an object, and I find that visualization useful. Let's talk about the word change. Earlier I said if we change first by appending, second changes. But if we change first by assigning, second doesn't change. The word change is the problem here. There are two different types of change in Python. Assignments change variables, and mutations change objects. We can use our pointers mental model to help us understand and differentiate between these two types of change. When we append to first, we're mutating the object, or we're mutating the object that first points to. But since second points to the same object, accessing second will show the same exact changed object as first. But if we reassign first, that changes which object the variable first points to. But that doesn't change that second variable at all. Second still points to the exact same object as before. Mutations change objects. Assignments change which object a variable points to. So, variables in Python contain objects. They point to them. Because of this indirection between variables and objects, there are two distinct types of change: mutations and assignments. Mutations change objects, and assignments change variables. So the phrase, "we changed x," is a bit ambiguous. Do we mean that we changed the variable x, or the object that x points to? Did we do an assignment or mutation? Now that ambiguity isn't always a problem, but keep in mind that phrase can be ambiguous. And this explains our first gotcha, why assigning two variables to the same thing can be a problem. When we point two variables to the same object, if it is mutable, that's when we can get ourselves into trouble. If we change that object, both of them will see that change. In Python, we have two different types of change, but we also have two different ways to ask the question, are they the same? We have the double equals operator for equality, and we have the is operator for identity. You can think of equality and identity as asking about model numbers and serial numbers. Model numbers help you find equivalent devices. Serial numbers uniquely identify a specific device. Equality asks whether two objects represent the same thing. That's like a model number. Identity asks whether they are exactly the same object. That's more like a serial number. If we have two variables, first and second, and we ask whether they are equal, we're asking whether they have the same value. This asks the objects whether they represent the same thing, like a model number. If we instead ask whether these variables are identical, we're asking whether they both point to the same object, like a serial number. Unlike equality, identity doesn't ask any question of the object itself. It just asks whether two references point to the same object. So equality compares the values of objects, while identity compares references to see whether they point to the same object. Now, all of this, though, you mostly don't have to know, because the is operator is very rarely used outside of comparisons to none. When we ask, are they the same, we usually want the double equals operator. Checking equality is much more common in Python than checking identity. So usually when you ask, are they the same, equality is what you want. So assignment changes which object the variable points to, and this is what an assignment statement looks like. But this is not the only way an assignment can look. Import statements also assign to a variable, and each iteration of a for loop assigns to a variable. And function definitions and class definitions also assign to variables. So we've just assigned to the variable e 5 times here. Any Python feature that updates what a name points to performs some sort of assignment. So there are lots of ways to make an assignment in Python. In fact, passing arguments to a function is also a form of an assignment. So when we call the square all function with a list of numbers, the local numbers variable within that square all function was assigned to the list object that we passed to that function. When we then mutated the numbers list by updating each of its indexes as we looped over it, we were mutating the original numbers list. That's why our numbers list outside the function changed. Function arguments are just variables, and all variables point to objects. Variable assignments don't copy anything, and neither do function calls. And this is the reason that in Python, functions rarely mutate the objects that are passed into them. Instead, it's very common to build a new list out of an old list with a for loop, or a comprehension, or with the many other features in Python that make new objects out of old objects. Unless your function is specifically designed to modify an object in place, return new objects instead of modifying existing ones. But wait, this assignment statement mutates the list. So is it an assignment or a mutation? Those are two different types of change, right? Well, it's both. Assignments, or rather assigning to a list index mutates the list, the same way that assigning to an attribute on an object mutates the attribute that object, or rather the object that attribute lives on. And in fact, if you squint hard enough, every assignment is also a mutation of some sort of namespace. It might not be a namespace that you can access through an attribute lookup on an object, but all variables have to live somewhere. So function arguments are just variables, and no objects are copied when a function is called. So that's 2 gotchas down, and 3 more to go. And the last 3 we'll kind of look at all at the same time. Up to now, we've been talking about variables. We haven't really talked about objects all that much, at least not how objects themselves work. So let's talk about data structures. In Python, data structures don't contain data. Depending on what we mean by data, at least. Data structures, what I really mean here is not necessarily, I'm obviously using clickbait, right? Data structures don't contain data. Sounds like a big, bold phrase. But what I really mean is that data structures don't contain objects specifically. Data structures in Python do not contain objects. So earlier I showed you a diagram that looked like this. Because we assigned 2 variables to the same value, both first and second point to the same list. And that list contains the number 9. But that list doesn't actually contain the number 9. This diagram should technically look more like this. The list can't contain the number 9. It can only contain a reference to the number 9. Variables can only point to objects, and objects can only point to other objects. Objects in Python cannot actually contain other objects, which is why if we put our list inside another list, the new list won't actually contain our list. The new list's first index just points to the original list object, which means phrases like a list of lists are actually shorthand for a list that contains references to lists, which is a mouthful, so we just say a list of lists. And the word containment in Python is slightly misleading, because objects cannot actually contain other objects. They can only contain references to objects. So when we ask whether one object contains another, we're asking whether one object contains a reference to an object that is equal to another object. which again is kind of a mouthful, so instead of saying all that, we just say y contains x. So let's revisit our 3 remaining gotchas. First, starting with our list of lists problem, where we use self-concatenation to build up a 3x2 list of lists. We multiplied the inner list by 3, which creates a list that points to 0 3 times. We then multiplied the outer list by 3, which makes a list that points to the inner list 3 times. So we end up with an outer list that has 3 references pointing to the same inner list. Concatenating list to itself with multiplication does not copy the list that's inside. So when we modify one of our rows, we're modifying the one object that all 3 indices point to. Index 1 in the inner list now points to the number 1 instead of to the number 0. But since all 3 outer indices point to the same inner list, all 3 rows show the same change. Because all rows are actually the same list. There are not 3 lists inside here, there's just 1. So don't use self-concatenation to build up a list of mutable objects. But what should we do instead? How can we fix this? Well, in this particular case, we could use a list comprehension. A list comprehension evaluates this 0 times 3 expression once per iteration, creating 3 separate list objects. Using our oversimplified diagram here, where we show our zeros contained in these lists, we can see that we have an outer list that points to 3 different inner lists. So when we mutate one of our rows, only that row changes, because each row is its own distinct list object. Changing one doesn't change the others. So our second of our 3 remaining problems, our dict.fromKeys problem, created a dictionary with each key pointing to the same value.
Oh, sorry, hold on a second.
No worries.
This happens.
Could have done it in between slides. That would have been-
I'm sorry.
Oh, there it is.
You doing it? Okay,
Yeah.
so it'll take the
It'll-
projector a couple seconds to
Okay.
fire up, but we should be back. I don't know why, it's on some schedule to like turn things off after a certain amount of time.
Weird.
It's a mutator instead of an assigner.
Your projector's back.
So here's when we use the dict.fromKeys here, we pass in our list of colors, pass an empty list. What we end up getting is all 3 of our keys in this dictionary point to the same empty list object. So when we append to one of these lists, we're mutating the one list that all 3 keys share, because there's only one list here, which means all keys show the same change, because they all point to the same object. So don't pass a mutable object as the default value to the dictionary fromKeys method. To fix this, again, we could use a comprehension, in this case a dictionary comprehension. So this evaluates that empty list literal once for each color in our list, creating 3 separate list objects. The whole comprehension builds a dictionary where each key points to its own list object. So when we append to one of them, only the keys in that list change. Or only rather that key's list changes. Because each value here is its own distinct list object, each value in this dictionary. Okay, so our last of our remaining 5 gotchas here is our to-do list problem. So this to-do list, we have a mutable default argument, which you may have heard as a problem in Python. When we create 2 instances of this class without passing a tasks list in, what happens is that both instances' tasks attribute points to the same default list object. So when we append to one of them, we're mutating the one list that both instances share. And that means that both instances show the same change. And in fact, we can actually look at the default value that's stored on the method itself and see that it changed as well. There's only one list here. And that empty list expression in our function definition was evaluated just one time when that method was defined. And the resulting object was then attached to the method. So mutating it through one instance changes the default value itself, which changes it everywhere. Now to fix this, we could use the list constructor to copy that default list. By using list of keys, the list function here, we copy the list each time that we initialize a new to-do list object. So when we create two new instances of this class without passing a task list in, each instance gets its own separate copy of that default list. And the original default is still sitting on the method untouched. So when we append to one of these, we're only mutating that one instance's list. And the other instance's list is unaffected, because each instance of this to-do list class has its own distinct list object. But this also has another benefit. If we pass the same list into this class twice, each instance gets its own separate copy. So mutating the tasks list of one instance will not affect the tasks list of the other. Also, because the list constructor will loop over any iterable that we give to it to make a new list out of it, this class now doesn't just accept lists, but sets, generators, or any other iterable that we could dream up we can now pass into this class. This is why classes that are meant to change an iterable that's passed into them will often shallowly copy that iterable in their initializer method. So that explains our last three gotchas. All three were due to the fact that objects in Python do not contain other objects. They can only contain references to other objects. So if we end up with multiple references to the same mutable object, we might get ourselves into trouble. A quick recap of what we learned. Variables don't contain objects. They contain pointers to objects. And assignments point a variable to an object. An assignment does not copy an object. So, pointing two variables to the same object is a problem if that object is mutable. But for numbers, strings, and other immutable objects, pointing two variables to the same value is fine, because you can't change the value anyway. Also, function arguments are just like every other variable. So when you call a function, each argument that's passed in is just another assignment, which means functions, or function calls rather, don't copy objects. So functions shouldn't mutate the objects that are passed into them unless that's the expected behavior of that function. Instead, it's common for a function to copy passed in objects either implicitly or explicitly when needed. And objects can't contain other objects. They can only contain pointers to other objects. So if you store multiple references to the same mutable object, you might get yourself into trouble. So be careful in particular when using utilities like dict.fromKeys to store references to a given object instead of copying, which will store references rather to a given object instead of copying it. And when you're writing class initializer methods, be mindful of whether you're storing a reference to a passed-in object or you're making a copy of that passed-in object. In summary, variables store references to objects, and objects can store references to other objects, but objects can't contain objects, and neither can variables. Also, function arguments are just variables, and so are attributes. But there are many odd corners of this topic that we did not cover, and I really don't have time to cover all of them. For example, we didn't discuss that variable scope at all within Python really. We didn't discuss hashability and what that means, how it relates to immutability, optimizations that Python performs around numbers, strings, and tuples, which honestly you really don't have to know, but people like talking about it for some reason. Arrays and direct value storage, and the fact that tuples can contain mutable objects. This URL, which is on the bottom of each slide in this talk, includes links to resources on some of those topics, as well as 2 other great talks by other Python community members that are related to this topic. Now, before we wrap up, I do want to address a common question related to this topic of variables and objects. Why does Python work this way? Wouldn't it be easier if variables and data structures contained objects and assignments copied the objects when we were assigning to them? Well, imagine if every assignment made a copy of an object. Copying objects all the time takes time and it takes memory. But also, how would you ever model parent-child relationships? Or any kind of relationship that involves storing a reference to an object instead of storing a copy of an object? Would we need to make a distinction between assignments that copied and assignments that made a reference? Other programming languages have done that before, and that requires an added layer of complexity in the language, which has its own trade-offs. Python's way isn't necessarily the right way, but most days, I really appreciate the trade-offs that Python made around this topic. Python's separation between variables and objects can definitely be confusing, but it's a pretty decent approach to a hard problem. Every decision has trade-offs, and everything is relative to its possible alternatives. Whether we're talking about a software feature or about politics, when we say, this thing is bad, we should always ask ourselves, compared to what? We should acknowledge problems with the status quo, but we also need to think deeply and honestly about real-world outcomes. And that's it. Thank you. Anyone have questions on anything? Or comments that you want to share in front of everyone as opposed to afterward? I also would love comments afterward, because by the way, I'm rehearsing this talk for a conference, PyCascades, that'll be in March, which, did you mention North Bay Python as well?
I didn't. You want
Okay.
to shout out?
Yeah, PyCascades March, North Bay Python is April, I think, and then PyCon is in May. And I mean, they're all the same time as us, right? Questions, comments, anything?
The only comment from the live stream is Kojo says hello.
Oh. Hello, Kojo. I didn't realize Kojo was watching the live stream. That's awesome.
He said he had to go to bed.
Oh, I would expect. It's not in our times out, speaking of sentence. The one thing that I do personally want to change about this talk is it kind of jumps around a little bit with the gotchas, and I haven't yet figured out how to indicate we're going back to a gotcha here. We're on a gotcha versus not. But if anyone has thoughts on that, feel free to share them with me afterward. Yep.
How would you, other than just doing the print statement and print the console, how would you test each of these? Just the way you did, say, I did this, and this is what the result was. Is there anything else that, if you have a complex system, and
Yep.
you do this one test in one place, how can you see how it modifies other things that downstream?
Right. It depends. So printing is one way to do it, but printing, it feels very manual, right? You're printing it out, you're seeing it visually. Kind of back to starting at ground zero with your question of how would I test in Python in general? Assert statements, typically. Assert this thing is equal to this thing, or this thing is in this thing, something about one object and another often. Sometimes just assert, something is true. But beyond just assert statements, PyTest usually is the framework I would reach for. Sometimes Python's built in unit test. But then how do you test the fact that something way over here changes and affects a thing in somewhere else in your program? And it very much depends in the sense that the idea of testing a little piece of something, a unit test, has its own value, but you do need to at some point mash things together and make sure it all works as a whole. The closer you can get to making something that I think is a black box test, you pretend that you're the end user, you do the things the end user would do, or you try to model those things, and then you try to assert things that really matter to the end user. That's kind of the best you can get. Sometimes that's not very good, though. The best you can get in the sense that if it's a web page, for example, I don't necessarily have assertions that say, well, we've got the color blue on the web page. Some things at the end of the day, you kind of still have to fall back to a human testing certain things manually. But yeah, that's, somewhere in my thoughts on testing, and that quite answers what you're asking now. Other questions about anything? Oh, yeah.
I would have liked to have seen some way to unravel it a bit, so that maybe a single command where you start saying all these matrices belong to first, second, third, fourth. It just turns into spaghetti going to the right side as you were showing the columns. But if there was a command where it could just have them going across the board rather than becoming spaghetti, like reassigning everything, however it is without all the different pointers going to different places. Is that clear?
It is not clear. I'm going to try to repeat the question here. You'd like to see some kind of command that makes things either shows the spaghetti that I showed or kind of cleans it up somehow. I think is kind of. I think we should maybe talk about that afterward because I'm very curious what you're asking, and I feel like we might need to sit on a computer together to make sense of it. But I want to know what you're asking, so let's maybe chat about that afterward or on Discord afterward.
Okay.
All right. Thank you. Right?
You can plug. Yeah, you can unplug. Switch it over to the full HDMI scene. Thanks, Trey.
Yeah.
Awesome. Hobson, are you all ready?
All set.
All set? All right. Hobson Lane is our second speaker. And Hobson's going to talk to us about a simple but effective OSINT Python SDK from scratch. Seems ambitious.
I'm not going to do it from scratch.
You're doing it.
I will show you what happened from scratch.
Your HDMI. Oh yeah, that'll work. Hopefully.
See if I can mirror it.
Let's see it yet.
Yeah, maybe now.
Oh, something happened. It's on the other screen.
Yeah.
All right. I'll let you take it away and figure it out.
Thanks.
Let me know if you need help. Switching.
There it is. There we go. Okay. So, I'll talk about a basic OSINT Python SDK from scratch. I had a really rough beginning of the month with a lot of cybersecurity attacks against me personally and some in real life that really kind of scared me. So I wanted to look into who they were and why they were doing it to me. So I went to the people I was trying to look at are overseas and India in one particular case. And so I went to Security Trails, which has a lot of DNS records for people and even things like email addresses and that kind of stuff if you're trying to look for individuals. And I was trying to look for like business records, and of course that's nearly impossible if you're looking for somebody in Bangalore, India. But so I put together this an SDK just to query the Security Trails API. And it's kind of an interesting pattern that you might use yourself whenever you have a complicated API that you just want to make simple and have a bunch of functions for it. So I've created this get. The core of it is this get function. It's just the request.get, but it takes a URL and then goes to that URL and then processes the JSON, puts all the headers in, handles logging of all of your requests and caching, so that I can do it live here today even without an internet connection, or if my Security Trails allocation has run out, because the free you only get 50 requests for free before they start charging you. And if you're not familiar with Security Trails, it's similar to Shodan and a lot of other open source intelligence tools that just are constantly out there pinging a bunch of IP addresses and domain names and trying to suss out things like subdomains and IP addresses and who owns what and how they're all connected. So here's some of the things you can do. So I built this. This is my own thing, extract links. Just visit a page and extract all the links. That way you can see if your web page is working, you can just use it on your own web page, or you can find out if there's cross links or if there's some links to nefarious malware on a particular site. Didn't find anything super interesting here except that all the links were broken at this particular domain name. And did discover a few subdomains within the page itself. They're not trying to hide them, so they're not really interesting, and none of them work. But digging a little deeper, you can get the history of when that domain name was registered and exactly what the IP addresses were in the past, and so that's a neat feature. And then you can also go to, you can get the IPv6 addresses if they have any. You can get the MX records if they have them. And again, you get the history of that. So you know whether they were using Gmail at one point and they switched to some other mail provider or whatever they're doing with their mail servers. A lot of these can be clues as to whether they're trying to hide themselves or whether they're legit. And let's see, you can get their name servers so you can figure out who's actually serving the page. Usually the registrar is the place where they're serving it, especially if it's an amateur. So in this case it was GoDaddy, you can even get their TXT records. This is what you use to verify that you own the domain name. So you can see what particular system they were verifying with by seeing how that TXT record is constructed. You can't actually use it to verify that you want it or anything, but it's because it's already been used and and you don't have control of the site to put that record there, and they're paired up with a domain name, and you can't use it for anything nefarious yourself. But it's interesting if you're just trying to investigate people. You can get the associated domains. I've never found anything useful at this particular endpoint for associated domain names. It's always empty. There's only one page, the actual domain name that you're looking for. You can get nearby IPs. Of course, there's tons of those because those are all on the subnet, and typically these things are a bunch of VMs on the same machine, and there's a lot of nearby domain name IP addresses, and you can get the domains. But sometimes if you're working with a botnet, you'll be able to see all the other IP addresses lined up in that same subnet or a nearby subnet. There was tons of these for this particular domain, and you can even see the ports for those IP addresses for the nearby IPs. And this one had hundreds of ports open at this particular IP address. And that AWS Global Accelerator lets you know that it's overseas, or it's trying to be an international website that's accessible quickly, sort of like Cloudflare and all those other distributed servers, speeding up your traffic. The real one that scared me was a taco truck. Sounds crazy, but and I'm still pretty sure that it was something nefarious because of all the crazy stuff that's going on with DHS and ICE and how they're doing surveillance. One thing you can look out for yourself, if you see your phone dropping down from 5G to 4G to 3G and LTE, it's a pretty good sign that somebody, especially if it's doing it incrementally and it feels like it's being forced and it's not just because you're moving around or hopping in your car or getting inside an elevator or something. If there's no external reason besides it just happens, then that's probably somebody who has a stingray somewhere that's trying to snarf down all of the IMSI numbers, IMSEI numbers, which identifies you as a person, as an individual with the telephone company, and your bill and everything, so they can use that number to track everything you do. In case they can't already track you by your license plate reader, if you're riding around on a bike like me and they're really trying to track you, they'll do that sort of thing. That's the kind of thing they're doing at the courthouse right now here in San Diego, in order to track people who come in there to check in on their visas and go to their court cases, and they'll often arrest them right there, or put once they have their MZ number or any other kind of tracking information like their car license tag, or even just an image of their face from the LPR cameras, they can now use those to track people's body, their gait, and their face. And so they use that to catch you while you're off guard at home, or while you're going from home to work where you don't have any support, and anybody like some of the patrol groups that I'm a part of that would go there to try to help you. So this particular truck showed up at a particularly interesting time in my experience with DHS, and so it made me suspicious. So I went to this place to figure out if it was a legit taco truck. Of course, it didn't have an order window. Any kind of intelligence agency putting up a front business is not going to let you go up to them and get the service that you're looking for. The truck is probably packed with electronics that are not useful for cooking tacos. But they are going to put up a website. They are going to put up a call service. They are going to make it. They might even deliver tacos as a catering business. This one turned out to pretend to be a catering business. Seemed really odd that he would be parked illegally right behind a cafe where a lot of socialist groups meet, and that's what was happening here. And this so anyway, these guys were much better than that other website I showed you at hiding what they're doing and making it look legit. And it very well could be legit, and it could be somebody who has a legit business and they actually retired. He could have retired from the fire department, where he's actually parked illegally blocking the fire trucks for an extended period of time. And so he could actually be a retired firefighter, but he's not likely to guard that truck with a bouncer that has tattoos all over his body and rides a pocket rocket just for guarding that truck. And anyway, that's the physical world intelligence, and it was a bit scary for me. And in the end, though, I couldn't find much on the domain name or the electronic signatures on the internet about what was going on there. It all looks pretty legit. The history of it is he recently he originally registered the domain name and first started his pages on Wix back in back in 2020, and just before that in 2019 he had tried it on Google, and then and I actually know that it's a he, and I have his name and email address from this particular investigation I did. Unfortunately, I didn't divide the page well enough so you can't see the full DNS history, but it's down there in the MX records and some of the other details about this particular site. So recently became active at the end of 2025, based on what I can tell from this particular domain history. And here's the TXT record. Nothing particularly interesting there, except that he registered his email with Gmail. I actually had a bunch of students doing this sort of thing to me as well at Mason College, where they actually had a video conference with at least two people that one that I'm certain was fraud, and another that may or may not be fraud, but these were actually fake people. So these were videos of people that were not actually answering my questions and there was an AI answering my questions and mouthing the answers on the video call, and trolling me, and in a really insidious way, pretending to be disabled, and so making it really hard for me to be strong with them and try to quiz them on their humanness, and so it was rough, and it's a really rough world we're living in right now. Gary Marcus and is one of my favorite naysayers about AI and its negative implications for society. And an early hero of mine in that whole fight was Daniel Dennett. And may he rest in peace. He died last year, but before he died, he and Marcus got together and talked about how we should make counterfeit people illegal as a capital crime in the same way we do for counterfeit dollars. And counterfeiting people is one of the most insidious things you can do to a society. And being able to, and making that legal and profitable, business for some of the biggest corporations on the planet, that's really scary for where we're headed. It's the kind of dystopia you see in Blade Runner and all those movies that we don't want to be living in. But that's enough. Let's see if the software actually works. One neat little trick. Let's look at the software real quick and show you some cool tricks that you can use in your own life with more fun projects. Where did it go?
It's on the bottom.
Yeah.
You can make it bigger, that would be great.
Yeah, sure, exactly. There it goes. It's taking its time. It's not.
You got one. One's good.
Whatever.
Something.
Shoot. Oh well. So here's that function I was talking about earlier. It's the heart of it. It's the most complicated one because it has that logging and even verbose features so that you can see the responses directly in the command line. And it also has the caching happening, and this is what you can use for testing. This is the thing that I think is most useful to you is if a lot of people would do stubs or mock databases in order to do integration tests or unit tests even. And if you have a cache mechanism, you can preload the cache during your tests, and that way you don't have to have mocks. And you actually have, and none of that code is throwaway code. All your mock code and all those data structures would be throwaway otherwise. But if you're actually using caches from when you were online and when you were able to query security trails or whatever API you're trying to hit or whatever long-running task output you're trying to cache, if you have it cached, that's something you can use in the real world to actually minimize your pings to the API or minimize the time it takes, the latency of responses to your user. So implementing caches, there's memoization is a common way to do that in Python. There's a memoization decorator. I just did it manually in a pretty similar way. I just attached the cache to my function as an attribute of the function. And so this is what's called a poor man's object or class, where you don't actually have to create a class definition. You can, because everything's an object in Python, even a function. So you can just you've essentially created a callable class, and I've just given it one particular attribute that I really need to be local to that function, and that's this cache. And I just populate it within the function itself. The keys, of course, are the URL or a part of the URL, the path of the URL that I'm hitting. and the values are the JSON object that URL returns. So it's really easy to do the caching and to mimic precisely, byte for byte, the responses you're getting from the API. Let's see, there's Security Trails has a ping. That's not useful except to verify your credentials. Then there's, these are all the other functions that you can run from the command line. So let's go to, great. So see if it works a little bit better. There we go. Now the Zoom's working. Okay, so let's hit one of those domain names. You can get the history, the entire history. Oops, maybe that one. Interesting. Maybe because I've been running it and it's corrupted the cache. Oh shoot! It's actually trying to go to hit the. Of course, you can see my history. I've just been doing those exact same queries, and they're all coming through just fine. Let's see if this one was that. I did history I did it on Artisan Taco. I didn't do it on Lumineo. I thought I did some stuff on Lumineo. Anyway, it's probably better if I just scroll back through the history so you don't have to watch it, try to go out on the internet that I'm not connected to. So this is the typical, this is the simple extract links where it got all these broken links. All of these are for different sub things like their privacy policy and all the different tabs on their page, and they're all just going back to the headline image on the page, which is completely useless. Similarly, the domain name itself, this is, you've already seen a lot of this in the slides, but that's how it works. You just call it as a function and away it goes. And I'm caching. One of the things that took me a lot of time is figuring out how I was going to cache my own function calls that aren't going to an API, what kind of domain name what kind of URL I was going to give, or path. And so I just settled on the function call itself, and with the domain name or the arguments to the function as part of it. And so I made it, that way it could shoehorn it back into that same get function cache. So both my locally running functions or my custom functions as well as the API calls could all be cached. So I could potentially have run them live now for some reason. Let's see if even the get links works. One problem is the one difference in the two APIs is I require the HTTP or HTTPS on the get links, so it goes. What did I call it? Extract links. Extract links. Well, that's working at least. At least the cache on my own stuff is working. Let's try one of the others. So I need to unify the API so it does the same thing no matter what you hit. Okay, there we go. That's hitting. That would hit the API of Security Trails if it wasn't caching. So that history thing, I must not have actually run that history query, that particular history query in the past. Otherwise, it would be cached. Subdomains are the most interesting ones. This gave me a lot of places. This is what you would do if you were a hacker and you were really trying to figure out what a back door to get into a place. You would visit all of these subdomains and see what ports they had open. You do a port scan on all of those. And I did visit all of these just to see what was going on there, and especially that test one, that looks like a really juicy target to figure out if there's some exposed things there that you could utilize. But none of these were actually functional. It was just a shell company that was pretending to have a lot of features. It was all vibe coded. Even some of the testimonials from customers, they were just images of people that don't exist and quotes that don't exist in the real world. They don't have any products, complete vaporware, worse than vaporware, it's kind of shamware. But anyway, I figured a lot out about a lot of people in this world, and it's making me a lot smarter, and figured out a good way to do caching and testing all together at once. Any questions? Wow, must have been a pretty lame talk. Yes?
Just a comment. If you are using requests, there is a requests cache module that does pretty much exactly what you want. If you pass a session object of the request cache type, then all your requests get written to like a SQLite database in a directory that you specify. And anytime you make another request to the same, has to be same scheme, same domain, exactly. It's all cached, including headers and everything.
Wow, that would be a lot, that would save me a lot of time.
Kind of related to what David was mentioning there, I was kind of wondering, your cache, just for clarity, is it only in the process? Like if you close Python and you reopen it, does the cache?
Oh, I save it to a JSON file, and I'll log everything to JSON lines, and I can convert from the JSON lines into the cache.json. So, yeah.
So it's not ephemeral, you actually can save it?
Yeah.
Cool.
And to bootstrap, because I didn't know about this limit at Security Trails, and I didn't have any caching mechanism built in place, but fortunately I did have logging to JSON lines. So I just built a function to create the cache post facto from the JSON lines, and then built all the code around it to maintain that cache while you're open, and save it when you're done. Or save it. Actually, I'm not saving it live, so I don't know when you're going to exit or Control C out of the process. So I just convert the logs to a cache whenever you feel like it, as a one-off function call. Any other questions or comments? Yeah, Alex.
I think I just missed it. What was why were you looking into Lumineo AI? Who are they again?
I don't want to say. It's a friend, and they're not bad people. It's just that they wanted me to actually help them fix their site, and I discovered some things that make their site unfixable, and so anyway, yeah, personal interest. You can think of it as pen testing, white box pen testing. Any other questions? Cool. Thank you.
Thanks, Hobson. We'll chat with you after about some of the other stuff, but we'll chat after.
Cool.
All right. Thanks, Hobson. Gordon, our last speaker, Gordon Pettus, is going to talk to us about a chemistry development project. Right? Hopefully. And then I'll set this here. Do you have HDMI or something else? Probably HDMI. Yep. Oh, there it is. I see it. It's on this side. Way to plug it in or no?
Yeah.
Otherwise it goes.
Ah, you have one of those. I've lived that life.
Yes, I don't have an energy efficient one.
I understand. I use Linux, so I understand very well. And do you have audio coming out of the laptop?
I shouldn't.
Okay.
It's related to life.
All right. This thing, which I left over here. Oh. And I do have a timer for you. You asked me to time you, so I have that ready.
Okay, I have a wife who has a hearing problem. Plus, she doesn't want to listen to me. So I have to speak up really loud, and so if I'm too loud, just let me know, and they can shoot me or whatever. Anyway, my name is Gordon Pettus. I'm a lifelong learner. I'm also, so you're not intimidated, I'm also a lifelong forgetter. And about 10 years ago, I took a chemistry course because I thought it would be interesting. There are a lot of subtopics in chemistry. One of them I found particularly interesting was stoichiometry. That involves the kinds of measurements that you do and the types of calculations that you do when you do a, let's say, a chemistry process, whether it's a reaction, a real one, or a homework, or a test, or anything like that. Now, the problem that I had with this is that, let me go ahead and close down a couple of these things here just a little bit. The problem I had with some of these things was that the teachers want you to write down everything. You can't just look at a problem and say, oh, the answer is this. For example, if I have a pencil that's 8 inches long, and I say, and the question is, how many feet is that? I can't just say it's 8/12 of a foot, so it's 2/3 of a foot. No. You can't do that in a class. You have to say the length is 8 inches times what's a foot? 1 foot divided by 12. So that 8 inches times 1 foot divided by 12 inches, the inches cancel out. So now you have 8 times 1/12. If you write all that stuff out, then the instructor knows what you're doing. Some of the processes were extremely complex. It might take 10 or 15 minutes to write out all these formulas and all the conversions and everything. And there are 2 reasons why the teacher would do this. Well, 3 reasons. One is to torture you. The second one is to be able to review all of your stuff so that they can say, oh, you did this wrong here. Why did you do that? Did you not understand? Is there something else that I need to teach? So there are a couple of reasons, and basically the idea is you have to keep writing all these down because eventually you want it just to be automatic. And that's the main thing. You want everything to be automatic. Well, this became really cumbersome, I would say tedious and annoying. So I decided there had to be a better way. By the way, this talk is for people who are new, and one of the conversations we have on our Saturday morning meetup is people say, well, I want to do a project. Well, what kind of project? Well, I want to play this little game or something like that. I wanted to do something that I thought was significant and that I was interested in. So I decided I would try to make a program that would solve these problems easily. I had already done one Python development program. It happened to be on getting a monster Sudoku puzzle and being able to have it solve itself or to help the user solve it. So I already knew something about tkinter. If you pronounce it differently, just get over it. So anyway, I was familiar with that GUI, and I decided I would create a GUI for this Python program and see whether or not I could get the program to work and solve the problems that I experienced in chemistry. Now, I already had a whole bunch of homework pages, so I had examples of the problems. So I wasn't creating something new. I was just trying to automate and make something simple that I'd already done. And I wanted to do this so that other people would be able to replicate this. And so let me see if I can find it. This is the GUI that I started out with. The top part is sort of irrelevant. It was things that I wanted to do eventually, but I may never get to them. The most important part is the middle part. Let me make sure. The middle part, I wanted to be able to calculate 6 different substances. and I wanted to be able to manipulate most of the properties of those 6 different substances. I needed to be able to do that independently. So I said, what do I need in a GUI? I could have studied a whole bunch of things like radio buttons and check boxes and stuff like that I might never use. I said, I'm not going to do that. One of the decisions I made was I'm going to limit the number of widgets that I'm going to use. So I'm going to have a container, and that may be different from your containment, but I'm going to have a container that has widgets. Those widgets can be buttons, they can be labels, they can be drop-down list box, and they can be text boxes. Now the text box could be something where you input a value, then when you finish with that, the computer does something, and then it can put an output in another text box. So that text box is really an input and an output device. I wanted to make all of these things easy. So, as a matter of fact, what I think I should, well, I'm not going to start over again. Anyway, in chemistry, you have 2 main types of substances that you normally work with. There are elements and there are compounds. So one of the things that you need to do is you need to write out the formula and then break down the formula and say, what do I do and how do I do it? So I'm going to switch a couple of these things off here just so I can start all over again. When the user starts by selecting the type of substance that they want. So in this case, on substance number 1, can you see all that? Substance number 1, I've got element. When I click on that, I need to save that value in the substance 1 container. The substance 1 container has all these values in a dictionary. I considered doing object-oriented programming, but I decided the dictionary was better. So when I click on this and I select elements, I need to go back to elements. When I click on this and select elements, the program does 3 things. The first thing it does is it stores that value elements in the substance type field. Then the program loads the list of substance, loads the list of elements by symbols. It loads it into this field here, and in the field right below it, it loads the names of the elements. So if you remember that, let's see, I want to use gold, but I can't remember what the symbol is. Or you can say, gold is AU, so I'll just select AU. Well, I'm going to select something else. Then I'm going to come back here and I'm going to select, if I can find it, I'm going to select aluminum. Now, when the program selects an individual substance, it goes out, finds a dictionary with all the values for that, and it copies all those values into the substance 1 container dictionary. So now that dictionary has the values for all the widgets, and it has all the values for the substance. In this case, an element, aluminum. By doing this, I don't have to repeatedly go out and try to find that dictionary. I can do all of my access just by going to this one container. When I select an individual substance, it will select, for example, I selected aluminum, so it says puts AL in the symbol widget. It puts the name aluminum in the name widget. Over here on the far left, it puts down a quantity. Now this happens to be the atomic mass of aluminum. But the atomic mass of aluminum, if you multiply it times a very large number called Avogadro's number, then that atomic mass is equal to that mass in grams. This is a constant. It works for any element. Now that mass is called a mole, and 1 mole is equal to, in this case, 26.98 grams. What's a mole? other than the little creature in the subterranean creature? Well, if you add up all the protons, all the neutrons, and all the electrons of a substance, in this case aluminum, you will get an atomic mass of 26.98. If you multiply that times 6.02 times 10 to the 23rd, if you multiply that times that many, then you end up with that atomic mass in grams. One of the things that you have to do frequently is you have to convert from grams to moles and back from moles to grams. So in this case here, I'm going to change this quantity from 26.98. I'm going to say in a chemistry lab, we're not going to use that much. We're not going to use that much material. So I may only use 3.5 grams. So I'm going to put in 3.5 grams there, and this is going to calculate a new mole quantity. I think, no, it isn't going to do that. Helps if I press the right button. So anyway, it calculates a new mole quantity. In order to do that, it had to take the input, 3.5 grams. It had to go out and get the atomic mass, divide 3.5 by the atomic mass, and that gave me the number of moles. Now, if I change the number of moles, let's say I'll put in 0.5 here, it can't just multiply the number from one box to another. It has to go out to get that atomic mass again. This is one of the things that might take you 5 or 10 minutes to do if you were doing it in a classroom, because you have to look up the numbers. You have to write down all the units and all the conversions and stuff like that, and that's just a real pain. I would say it's tedious at best. So anyway, I have just proved that I can convert from grams to moles and moles to grams. I'll switch to something else here, because see, this is the GUI that I used when I was developing my program. But this is the GUI of the website that I eventually created. And here you can see that I have elements, I have 3.5 grams, I have the same number of moles. Now, let's see, I need to change something here, because I'm going to need to change this to 1. And I'm going to need to change this number over here to 1, because I thought about restarting this. And I'm going to change this number over here to 3. Oops. Now, this is the kind of problem that you would have in a chemistry class. We're going to start off by creating aluminum chloride. I have the formula here, AlCl3. That means that there is 1 aluminum atom and there are 3 chlorine atoms. Or, since we know about moles, there's 1 mole of aluminum and 3 moles of chlorine. Over on the left side here, I have aluminum, because I'm going to combine aluminum with chlorine. And down below that, I have chlorine. Now, up here I needed 1 aluminum and 3 chlorines, so I've changed the mole quantity to 1 mole and 3 moles. So now I have what's called a balanced equation. By the way, this is one of the things that you have to do an awful lot of. This would take me between 5 and 10 minutes to set all this up on my homework paper. Now, since I have a balanced equation, I'm going to go up here to this little dark button that says, in white letters, equations is balanced. I'm going to click on that. Well, okay, come on, turn black, do something there. Anyway, when I click on that, it sets a flag that says the equation is balanced. It also sets up, it takes all the mole quantities that I had, and it puts them all on the list. Because later on, I'm going to need to calculate ratios between one substance and another substance. So now I'm going to see if, okay, there it's worked. So now I'm going to go over here. I've set up the equation. Everything is balanced. I'm going to go back to my 3.5 grams of aluminum and click on that. So now I've changed the number of grams, the quantity of aluminum. What is the quantity of chlorine, and what's the quantity of aluminum chloride? How much aluminum chloride am I going to end up with? Well, I could do all these calculations. Again, that would take me probably 10 minutes. But instead of that, I'm going to go up and I'm going to click on this button that says balance equation. It probably should say rebalance equation, but it says balance equation. I'm going to click on that, and what the program did is it took the mole quantity for substance 1, and since there's a 1-to-3 ratio between substance 1 and substance 2, there was a 1-to-3 ratio, so it took this mole quantity in substance 1 and multiplied it times 3 and put it into substance 2. When that mole quantity of substance 2 changed, it changed the gram quantity because it did mole to mass calculations. It did that automatically. Over here on the right, in substance 4, I changed the 3.5 grams to moles, and since there was a 1-to-1 relationship between the aluminum, alumina was an element, and the number of aluminum atoms that it was in the compound, there's a 1-to-1 relationship. So all the program really had to do is it had to take the mole quantity for substance 1 and copy it over into substance 2. So that happened automatically. Once that mole quantity was changed, then it changed the quantity. So now, if I have 3.5 grams of aluminum and I have 13.8 grams of chlorine, I will end up with 17.29 grams of aluminum chloride. This saved me probably 20 minutes of work just writing out all the formulas. Now, can you imagine all the formulas that you might have to write out if you were taking an hour or 2-hour test? It would be, as I said, tedious. I was able to do all this with just a few clicks of the mouse and a few entries. Basically, I put in an entry for a number of grams, and it did all the rest of the calculations. That was a project that I completed, that I started several years ago. I did not need to solve all of the problems in chemistry. All I needed to do was prove that this worked. Once I proved that this worked, I had a choice. I could solve more of the problems, or I could immediately develop it as a web application, and I'm not that familiar with the web stuff, so I just hired a web developer. He converted all of this stuff from the Python over to this web page, which you can see right now. And then after he did that, I was able to do additional development. Now the web page obviously has HTML, it has CSS, cascading style sheets, and the program is written in JavaScript. Well, once I had done some of these basic things, all I had to do was learn a little bit about JavaScript, and I could develop the project even more. Because if I said, I need to multiply this times this, or I need to take this, multiply it times this, and convert it to something else, so I divide something else. If I had that model, then all I had to do was figure out what I was going to do in JavaScript. So I learned some JavaScript, I made some improvements, and all that stuff seemed to work fine. The only problem with this whole thing is that I took this back to some of the professors, and they refused to use it. They refused to let their students use it because they wanted their students to grind out all of these things. So I stopped developing it because it was getting expensive. I was spending a whole bunch of my time doing it, and now life has gotten in the way, and so I really can't develop it much more. But I have this website that can do some of these basic things, and as soon as I get some of my other problems out of the way, then I can get back here and develop this, and I hope that I can get somebody to actually use it and even pay me to help develop it more further so that I can help more people. So I started with a project that I thought was achievable. I wasn't creating anything new. All I was doing was automating some things. If you're starting a project and you're not creating anything new, can you do everything by hand? Either write it out on paper,
or make a simple Python program to do one thing at a time, or maybe use an Excel sheet. Can you do all those things so that you're not creating anything new? If you can do that, then you can create a project, a Python project. Because Python is a good development environment. Questions? Yes?
Are you familiar with smiles as a representation of longer chemical formulas?
No. I wanted to be able to have three, just to prove that this works. I want to be able to have three substances as reactants and three products. That would prove that everything would work. If I did that, and let's say if I needed more, I could add more containers. I could put 10 or 20 or any number of containers in here and have all those different substances and still do all the same calculations.
Do you know whether those substances will react in the way that those three substances, if you put them together,
Yeah.
they react?
Yeah. I took a real substance, aluminum chloride. Now, typically, and here's a problem with the system. Typically, chlorine is a gas. Now, chlorine is also listed as Cl2. I just put it as Cl1 because I just want to simplify it. But if I change this to from grams to liters of gas, then it calculates the quantity of liters of gas. So it can do a whole bunch of those kinds of things. Go ahead.
It's not simulating the reactions, it's just giving.
No, all it's doing is doing the calculations. Now, one of the things that I wanted to do, and I got it down to the bottom here, it says equipment, energy type, energy amount, catalyst, side effects, byproducts, variables, value. Eventually, I wanted to be able to do all of those things so that I could say aluminum chloride, it uses this equipment. It cooks everything at 300 or 700 degrees Celsius. It does all of these things. So that was what I eventually wanted to be able to get to if there was enough demand. Yes.
Do you know of any databases of those pieces of a reaction and the reactions that actually work?
Well, if you Google a particular compound, it will say these are the components, this is the formula, this is the process. So it will tell you the whole process that it goes through.
Okay.
By the way, just to show that I have a little bit of sense of humor sometimes, I needed to have temperature units, pressure, and pressure units. I need to be able to change from one to the other. In a typical laboratory, school laboratory, you would not have something like aluminum here. You would not have chlorine at 0 degrees Celsius, which is what the standard temperature and pressure. You might have it in a container, and that might be at 0 degrees Celsius, but you need to be able to make adjustments for all those things. Well, you need to be able to use different temperatures. The display temperature is Celsius, but the actual calculations for the gas volume are in Kelvin. So I started with what's the most frequently used. It's in the lab. It's Celsius, then maybe Fahrenheit, and then Kelvin. But I decided not to do that. So I didn't have it in here. I had it in my other one. Anyway, I changed it from CKF to KFC. I don't know that anyone would ever have noticed that, but anyway, that was one of the things I thought, okay, I'm just going to bury this and see what happens. Okay, any other questions? Yes?
For the Python GUI, how did you make that? I'm not really too familiar with Python GUI.
For the what?
The Python GUI. How did you make the Python GUI?
Oh, well, I had already worked with Python before. So I knew about the GUIs and things like that. I knew about, not the GUIs, I knew about the different types of widgets. I could make a page, I could make containers. In this case, I think the container was called a frame. The widgets, I only used a certain number of widgets, figured out how to use those, and so on and so forth.
Are you using a particular library?
Just Tkinter,
They built it.
Okay.
because that comes with the program. So that anybody who wanted to, who used Python could say, oh, okay, this thing here is wrong, and therefore I can make this change. By the way, one thing I didn't show you that I should have is I did not want this thing to be a black box. So over on the left-hand side here, I have a little thing. I have general instructions. I have specific instructions for how to use some of the things, but I have an explanation page. It's sort of an accordion thing. It opens or closes. What I want to do is I want to be able to log everything that I did. So when I was writing the program, I'd say, I'm going to print this. I'm going to print that. So I wanted to do is I wanted to say, for example, at the top here, the user selected S1 type to be element. The user selected AL, this user selected substance AL. Program set substance name to aluminum. Units equal grams, and quantity mass equal 26.98. I wanted to have all of this documented so that somebody who was just starting to use the program could say, can I really trust it? If they read through the explanations, they can say, yeah, this explains everything that he did, everything that I did, and everything the program did. So they can use that to validate the program works. The other use is if a student is using this, the student can say, I did this, but I don't remember the process. So if they look through the explanation should be able to say, you did this, the program did this, 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 and this. So that helps the student. Remember what they were supposed to have remembered. It's a reinforcement technique. Other questions, or everybody asleep? We done?
I think we should wrap up.
Okay.
Thank you. Thanks for it. Appreciate it. That was great. So I think probably an interesting part might be how somebody converted the GUI from Python to JavaScript. That might be kind of an interesting.
Well, that would just be a web developer.
Okay.
They would say, oh, okay, I've got this GUI, and so I have all these widgets. So you just create all those widgets in HTML. Then you say, oh, okay, well this is really ugly. So now I'm going to use CSS to make it look better. Okay, so let me get this.
Appreciate it. I mean, we're pretty much wrapped up. Oh, yeah. Anyway, that pretty much is the end of the meetup. Thank you for coming. Thanks again to our speakers. Thanks to Qualcomm and Cloudflare for sponsoring. And thank you for coming. Please sign up at a future meetup to give a talk. You can do it. All right. Thanks. I didn't switch the video. I didn't. Switch it to this. Okay. Oh,